Alright, thank you so much for joining us today. In the previous video, we talked about integration by substitution. That is the U substitution. In this video, we are going to talk about integration by part. So as I said, integration by part is coming from the product rule, right? So I'll do short and then prove that. But what is the formula for finding integration by part? We have U divin, and we are saying that this is the same as U vin minus vin du. So this is the formula that we need to use to solve integration by parts. We are going to take example on indefinite and definite integrals. Let's start. So now we just record that integration by part this is the formula here. So we want to go through this process and see. Now here is like the same thing as U substitution. How to choose your U and your divin is very, very important. And I'm going to show you different functions and how you can choose your U and your divin. Right, so let's consider the first example. So we have this function here, and the question is saying that if we are letting U to be equal to X, then what is your divin? So one thing that you need to know is, now here, if I choose X to be equal to U, then anytime I'm dealing something like this, I'm comparing this to this here. So you can see that the integration goes with the integration, and here we've chosen U to be equal to what? X. So X will also goes with the U. So everything left will be for divin. So divin is everything left here, and then e to the power 3x is 3x dx is what is also left. So it means that here my divin should be equal to e to the power 3x dx. Now the idea is that, and they've given us that U should be equal to X. So here U is equal to X. Now let me give you the trick here. Anytime you are dealing with integration by part and you have exponential function and a polynomial function, what you just need to know is always your divin is going to be the exponential function dx. Always, whenever this is exponential function and you have a polynomial function here, and then the polynomial function, which is multiplying the exponential function, becomes your U. Always. That's what you just need to know. Now with the choice of U and divin in part A, what are your du and vin equal to? So anytime you have divin and U, you can use U to get du, and you can use divin to get your vin. So let's see how. Now U is equal to X. So for me to get du, then I need to differentiate this with respect to X. So du over dx is equal to 1. And this implies that du is the same as what? Dx. So that is 1. I can also use this to get my what? Vin. How am I going to do that? Having divin to be equal to 3x dx. Now I'm going to integrate, because this is d, meaning that we've differentiated the function. So just integrate both sides, and this guy will cancel this guy. So I'm going to have vin. And when I integrate an exponential function, we know how to integrate an exponential function. Maintain the function and divide it by the derivative of what is on the top, which is going to be 3. Here we are not going to add plus c. So this is our du and this is our vin. Now use the integration by part formula to solve this. So recall this. Now if the left is equal to the left, then if I say that this is equal to, then the right here should be the same as the right here. Is that right? So it means that what is here should be the same as what is here. So this should be equal to the right here, right? But the right here, we know U to be equal to X. We know vin to be equal to this. So now we are going to have x e to the power 3x divided by 3 minus, because this is minus, integration of vin. So we know that vin is equal to e to the power 3x divided by 3, which is here, then times du, but we know that du is equal to dx. So we are going to have this one to be equal to dx. Very simple. So this is going to give us e to the power 3x divided by 3. I can factor 3 out. 1 over 3 out and have something like this. So what I'm going to do is I need to integrate this again. So this is going to give us e to the power 3x divided by 3 minus 1 over 3. And when I integrate this, I'm going to have e to the power 3 divided by 3. So maintain the function divided by the derivative of the top plus my constant. So finally, I have e to the power 3x divided by 3 minus e to the power 3x divided by 9 plus my constant. So this is how we integrate an exponential function. I will take 2 or 3 more examples on exponential functions, and then we move to learn functions and other functions too. So now this is definite. So let's see how we can go through the definite. So as I said, here we are using integration by part because we cannot use u substitution. So the first thing to do is choose your u and your dividend, right? Because we know the formula for finding integration, right? So if you want to see, recall that u dividend is equal to u vin minus vin du. So here my u should be equal to the polynomial function, which is 3x, and my dividend will be equal to e to the power minus 2x dx. So my dividend is always the exponential function with dx, and then everything left is for u. So looking at the right hand side, we need du, right? So we need to differentiate this with respect to x, and we get 3, meaning that du will be equal to 3 dx. Then looking at this one too, we need vin. So let's do that. Integrate both sides. So vin will be equal to, we said for us to integrate an exponential function, maintain the function and divide it by the derivative of what is on the top, which is minus 2x, and this is going to give us minus 2. So everything is here. So all we just need to do is now this to the power infinity 3x e to the power minus 2x dx will be equal to u times vin. So u times vin is going to give us minus 3x e to the power minus 2x divided by 2 minus vin minus 2x divided by minus 2 times du, which is this 3 dx. Now remember, we have limit on it. So this one I'll just put something like 0 to infinity. So this is going to give us minus 3x e to the power minus 2x divided by 2. This is going to give us plus 3 on 2 e to the power minus 2x dx. I'll still put 0 to infinity because I'm not done integrating. Now this is going to give us minus 3x e to the power minus 2x divided by 2 plus 3 over 2x. And we saw that when I integrate this, I'm going to have this divided by minus 2 from 0 to infinity. So now that I'm done with the integration, now I plug in the infinity and then 0. So let me simplify it a bit, and then we just take it from there. So this is minus 3 over 4 e to the power minus 2x from 0 to infinity. So let's plug in infinity. Now note that e to the power minus infinity is equal to 0, right? So it means that when I plug in infinity inside here, I'll have e to the power infinity, and this one will go to 0. When I plug in infinity here, this one too will be going to 0. So this is going to be 0 minus 0 minus, then I plug in 0. When I plug in 0 here, since this one is 0, it will multiply everything here and get to 0. Or let me just plug them in for you to see. So minus 3 infinity e to the power minus infinity divided by 2. Let me shift this one small. Then minus 3 e to the power minus infinity divided by 4 minus, plug in 0, minus 3 times 0 e to the power 0 divided by 2 minus 3 over 4 e to the power 0. So when 2 times infinity is infinity, so get minus 2 infinity here. The infinity here, when I plug in 0 here, and I have this. Now this is 0, so this will go to 0, and this also go to 0. So I'm going to have 0 minus. Now 0 times everything here will be 0, so this one too will be 0 minus. And then e to the power, this is going to be 1, so I have this. So this is going to be minus minus 3 over 4, and this is 3 divided by 4. So this is definite. So I need to have a definite result. And let's look at B, still exponential function. Now this exponential function here, we can see that the polynomial function here is squared. So it means that here we are going to take the integration by part 2 times. Let's see how. So as we said, let your div to be equal to, always choose your div first. So your div should be equal to the exponential function dx. Then it means that everything left is now for u, which is going to give us 5x squared. So using integration by part, we need vn. So we need to integrate both sides to get vn. So vn should be equal to e to the power 3x divided by 3. As we know, maintain the function divided by the derivative of the top, and du over dx will be equal to 10x, and du will be equal to 10x dx. The reason why this one we are going to do it 2 times is when we found the du, still it involves x here. So using the integration by part formula, this is going to be something like this. Let me put this one beneath it. So we know that this is u times vn. So u times vn, I'm going to have 5x squared e to the power 3x divided by 3 minus vn. So vn is e to the power 3x divided by 3 times du. Du is 10x dx. So this is going to give us 5x squared e to the power 3x divided by 3 minus 10 divided by 3. Then when I multiply this and this again, I'm going to have x e to the power 3x dx. So I have another x here, so I need to do integration by part again. Do you see that? Good. So what I'm going to do is I'm going to just pick this function here and solve integration by part again. So I'll just write 4x e to the power 3x dx. Here to the same thing, pick your div first, which will be the exponential function dx, and here my u is x. So I'm going to have div integration this dx, which we have even done it here already. So vn will be equal to e to the power 3x divided by 3, and du over dx will be equal to 1. So du will be equal to dx. So for this one, I'm going to have x e to the power 3x dx, which is equal to, we want to apply the by part formula. So u times vn. So I'm going to have x e to the power 3x divided by 3 minus vn times du. So I'm going to have e to the power 3x divided by 3 dx. So here we don't have x again, so we can just finish it from here. Divided by 3 minus 1 over 3 e to the power 3x dx. So this is going to give us x e to the power 3x divided by 3 minus 1 over 3. Integrate this and have this divided by 3. Right? We can add plus c, or we can just leave it like that. Okay, let me add plus c here because we are done with that. Or c1. So this is going to give us e to the power 3x divided by this minus e to the power 3x divided by 9 plus c1. So let me call this one equation 1, right? And call this one equation 2. So that I can say that put equation 2 into equation 1. So we want to put this equation here into this, because we know that this one here is equal to what is here. So we are going to have our integration to be 5x squared e to the power 3x dx to be equal to 5x squared e to the power 3x divided by 3 minus 10 divided by 3 times. Now this guy here is equal to this. So I just plug it in there. So x e to the power 3x divided by this minus e 3x divided by 9 plus c1. Here you can decide not to add the plus here. Then when you come and do the substitution, you add the plus c here. or you can do this one. I will show you what will happen so that this one will disappear. Good. So this is going to give us something like this: 5x squared e to the power 3x divided by 3. Multiply this, and this is going to give us minus 10x e to the power 3x divided by 9, plus multiply this, and this is going to give us plus 10 e to the power 3x. 9 times 3 is 27. Then when I multiply this one by this, I'm going to have something like minus 10 divided by 3c1, and this is a constant, so this one can be replaced by c. So I add plus c. But if you don't want trouble, then you can just ignore this guy here and then add plus c without adding c1 here, and then you have something like this. So this is the integration for this function here. Good. So I think we've done a lot of integration involving the exponential function. Let's pick the one which goes with the natural log. Now, as I said, always how to choose your vein, u, and the vein is what is very important here. Now with the natural log function, it basically we choose the length function to be u. So always, anytime you have the length function, right, choose, or when you have integration which involve the length function, choose your u to be equal to the length function. Everything left is for the v. So I've taken this one out. What is left? X squared dx. So this is equal to x squared dx. Good. So what is du over dx? When I differentiate length, I have 1 over x. So du will be equal to 1 over x dx. Let's find vein. So integrate both sides. This is going to give us vein to be equal to x to the power 3 divided by 3, right? Then what happens? So basically we are going to have something like this. So using the integration by part formula, we need to multiply u to vein, which is going to be 3x to the power 3 divided by 3 ln of x. So u times vein minus vein, which is x to the power 3 divided by 3. Then we multiply it by du, which is 1 over x dx. Good. So now this will be equal to 3 ln x minus, I can factor 1 over 3 out, and here one of the x will cancel one of the x here, so this one will be left with x squared dx, and then this is going to give us x to the power 3 divided by 3, and this is minus 1 over 3. We've already integrated x squared here, which we had this, so we are going to multiply it by x to the power 3 divided by 3 plus c, and this is going to give us x to the power 3 divided by 3 ln x minus x to the power 3 divided by 9 plus c. So that is the length function. We are taking more example with the length function. So anytime the function involves the length function, we choose u to be equal to the length function. So that's what we do. So here my u first, which should be equal to the length function, and my vein will be equal to everything left, which is x dx. So let's find du over dx. This is going to give us 1 divided by 3x times 3. So we know how to differentiate the length function. 1 divided by what is inside the parentheses times the derivative of what is inside the parentheses. So simplify this, and we are going to have du over dx to be equal to 1 over x, and du will be equal to 1 over x dx. Let's try and solve this one too. The vein integrate, vein should be equal to x squared divided by 2. So we've gotten everything sorted out. So let's try and then go through the process. So this is equal to, you remember the formula is u vein minus vein du. So this one, u times vn is x squared over 2 natural log of 3x minus vn is x squared over 2 times du is 1 over x dx. So du, vn, and u, that's what we use. So x squared over 2, don't forget we have the limit, so 1 from 1 to e, so this 3x minus 1 of the x will cancel 1 of the x here, so I'm going to have 1 over 2 x dx, and then let me bring this guy down here. Then integrating from 1 to e, because this is definite, x squared over 2 natural log of 3x minus 1 over 2. When I integrate 1 over x, when I integrate x, I'm going to have x squared divided by 2 from 1 to e times, so x squared divided by 2, 3x minus, this is x squared divided by 4, 1e. So all we just need to do is just plug them in. So this is going to be e squared divided by 2, 3e minus e squared divided by 4 minus, plug in 1 squared divided by 2 natural log of 3 times 1, what is 3, then minus 1 squared divided by 4. Simplify that, e squared divided by 2, then 3e minus e squared divided by 4. This is going to be minus then 3 divided by 2 plus 1 over 4. So this is what you're going to get for this. So this is basically the length function. Anytime I have the length function, what I need to do is my u should be equal to the length function, and then everything left is going for my div. So with the exponential function, we choose div first. Good. Now let's look at this one also here. Now this one, which one are we going to choose for our du or div? Now anytime you have a polynomial function and then the trig function, you choose your div first before you choose your u. So my div should be equal to the trig function. So I'm going to have cos s ds, and everything left is for u, which is left with x. So the trig function dx. That's basically what we need. So let's find for du is equal to dx. Let's find for vn here. So you see that we follow the same procedures, right? So vn should be equal to, when I integrate cos, I get sine x. So this is going to be giving us something like this. Integration, no, vn times u, so I'm going to have x sine x minus vn is sine x times du is also dx. So this is what I'm going to get. So this is going to give me sine x minus, when I integrate sine x, I get minus cos x plus c. And this is x sine x plus cos x plus c. Quite very simple here. So that is, let me give you a trial question to try. So as you know, with exponential function, always choose your div to be equal to the exponential function dx, and then everything left is going for u. With the length function, choose your u to be equal to the length function, and then everything left will be going with div. Then we saw that with trig function too, we pick our div to be equal to the trig function. Let me say cos s, then everything left will be going with what? U. So that's what you need to put in mind or have it in mind. So try this and leave your final results in the comment section. So I'll end the integration video here. The rest of the video we are going to take further calculus. So we will continue integration from there, integration and differentiation from there. So the next video that's going to come after this one is going to be quizzes and, let me say, sample questions, and then questions that can prepare us towards our final exams. So see you in the next video.